Hey everyone, welcome to the second video on the center of mass 2D point mass systems. So you should have already seen the first video that kind of goes through this idea of point masses in 2D and just finding the center of mass for those guys. And now we're going to kind of continue with this idea right here of if I have an actual shape and not just points, how do I find the center of mass of that shape? And all of our shapes here are going to be made out of kind of squares and rectangles. The ideas that we're going to learn here apply to other shapes as well, so make sure to point that out too. So the first one we're going to take a look at is just this number one, part A right here. And you should have several acrylic pieces in your kits, so you should have one that looks like this, kind of blue. There should be another one that's looks like this guy and this little bee over here. So I don't remember what colors, it might be orange or green or something like that, but you should have at least 3 of these guys in your kit. So let's go and take a look at this first one. So the idea with these guys is I'm going to divide up my shape into several pieces that I can easily find the center of and find the area of. So we're going to think of our mass as kind of the area on these guys. So I've already divided up the picture down here, but I'll go ahead and do it again kind of right here. So I'm just dividing this up now. If I wanted, right, I could kind of draw a line across here if I wanted to divide it that way. So there's lots of ways you can kind of divide these. I'm just going to do something like this. So, and it's kind of hard to draw a straight line. You'll have to imagine these are straight. All right. So once I got my rectangles and squares, the idea is I'm just going to find the center of these. So this one's 3 tall, so like 1.5 right there, 2 wide, so just 1 from the edge. So there's that center. This one looks like it's 4, so 2 up from the bottom. Again, 2 wide, so right there in the middle. This one's 3 wide, so 1.5. And 2 tall, so just 1 up from the edge. And then this one's 2 by 2, so just 1 from the left and from the bottom. All right, so once you got those, the idea is going to be kind of the same as we did for point masses. So essentially now I have all of these center of mass points with all of the mass of this rectangle concentrated at that point. And what we're going to do is assume these are kind of uniform density, thin shapes that aren't going to vary, from top to bottom or left to right. They're going to be the same density all the way across, which means that the area is really proportional to the mass. And I can just use the area as the mass for these guys. So this area is going to be like 2 by 3, so 6. So I can think of this as a mass of 6 concentrated right here at this point. We'll say this is 0, 0, and just go over 2, 1, 2, 3 and a half. So this would be 2, 3.5. Same thing on this one, so you're just going to count all the masses, identify the centers. So this one's going to be mass 8 at, looks like this is over 4, and we'll go up 1, 2, 3, 4, 5. There's 4, 5. This one is over 1, 2, 3, 4, 5, 6 and a half. So this one, actually we'll put the M, so M is 6, and we said this is over at 6.5, and a height of 1, 2, 3, 4. So there's that. And this one, mass of 4, 1, 2, 3, 4, 5, 6, 7. So center's at 7, 2, and mass there's just 4. So I got 2 by 2. And then go through all the computations like you did for point masses. So we'll say our moment about the y-axis, we're just going to take all of these x-coordinates, which are distances from the y-axis, times the masses. So you can go ahead and write those down. Alright, so I got all these written down. So we got our 6 times 2, 8 times 4, 6 times 6.5, 4 times 7 for all of those masses times the x-coordinate. Again, that's distance from the y-axis. That's why it's called my moment about the y-axis. All my moments about the x-axis, which is just the masses times the distance up from the x-axis, so these y-coordinates all listed there, and then total mass, just adding up all the areas in those blocks. So I should come up with, for this my, I get 111. For the mx, I get 93, and for the mass, 24. To get our center of mass, all right, so x bar is going to be this 111, so that moment over the about the y-axis, so that 111 over 24, and again I can think of this kind of x-coordinate center of mass matching with the x-coordinates of those points, so this is going to be 4.625. The y bar, this is going to be the mx, 93 over that 24, and for that we come up with 3.875. So if I were to plot those up here on my shape, I'm going to go to, let's see, I'm going to go to this 4.625, so 1, 2, 3, 4, a little bit more than 4.5, so like right in this kind of area right in there, and then 3.875, so 1, 2, 3, 4, but not quite 4, just a little bit short, so like right around that area right there. So this dot right here would be my center of mass. And you can go ahead and kind of put a dot on your shape where that's going to be. So you should have this dry erase marker in your kit that you can go ahead and plot that on your shape. Just mark it down, and then go ahead and put it on this little stand right here to make sure it balances. So these should balance right on that dot where you put your center in. I know we're kind of estimating where these are. We aren't super precise, but that's why the top of this fulcrum stand is a little bit flat and not just a super sharp needle point. Balance is very, very sensitive, so if you're trying to balance on a needle point, you have to be super pinpoint accurate to get that to balance, and you can't have any deviation at all. Even like you would probably need like some calipers to actually measure that physical distance of a lot of these shapes. So we're gonna fudge that a little bit for our purposes and just make this stand a little bit flatter there on top, so that we can kind of just estimate a little bit on these guys where they're gonna go. So it should be good enough to go ahead and just mark a dot, eyeballing it and then putting that on the stand. What you'll want to do is go through the rest of these shapes. I'm not going to do all 4 of these, but go through and just compute the center of mass, mark it on the grid. For these last 2 where you actually have a shape, go ahead and put that down as well. For this one, there was a little bit of error in the cuts when they cut the actual pieces, so go ahead and assume this is like right at the halfway mark right here. Go ahead and assume these are 1 unit wide. I think it'll be close enough for our purposes. So this is winter 21. If you're later than that, hopefully we'll have some more accurate pieces, and you may see a slightly smaller shape that corresponds with the grid lines a little bit better on these guys. The grid that you're using does have the small squares on the back for most of these. So not the big squares, but the small squares for these guys. So if you're looking at what side of the grid should you use the one with the small squares. And do confirm that these guys balance right here. On the last page, again, you'll have some homework you can go through. There's also this, you should have on yours a link at the bottom that you can actually create your own shapes and go through and kind of figure out, where the center of mass might be for some of those. One question I sometimes get people just don't know what to do when they look at this part C. But I'll go ahead and give you a hint. I'm not going to work all the way through it, but I'll give you a hint on this one. You can do this the same way we did the last one with using the area of these circles. You know where the center of mass of a circle is, so it's going to be right there at the center of the circle. And just find these point masses of all these shapes. So the big circle, the small circles, find the center, find the areas. But the holes you're going to use as a negative mass. So you can actually put holes and stuff and treat that as a negative mass for these guys because you're taking it away. So even if I came back to one of these shapes and I wanted to put like a little hole in here, I could treat this, say, as a big rectangle minus 2 holes, and I can do it that way. So if you want to do that where you're kind of filling this in, down this way and right there, I could actually do this with just 3 shapes instead of trying to do a whole bunch of, I guess only maybe 4, but you could do it with 3 if you thought of this as a big rectangle minus 2 squares that are in there. So you can treat holes the same as you do other shapes that you add on, but with a negative mass for those guys. So no matter if it's a square, rectangle, circle, you can do the same thing for those guys. The next time we'll get into much different shapes. So maybe I have like a semicircle on that. How would I find where the center of mass is on that? That's not going to be necessarily just halfway up or anything like that. You got to find the height of where that center of mass would be on this guy, and maybe I want to attach a rectangle to that, make a mushroom. So even the shapes we do in the next section, you can use this same idea of I'm just composing a bunch of shapes that I know the center of mass of, I know the area for the mass, and then I can do this kind of point mass idea on these 2D shapes. So that'll do it for this one. Again, you might want to try this one with the holes, just see where it goes. Try it with adding the shapes, and you can even compare, do they come out the same? They should. So, all right, well, that'll do it for our 2D point mass area video.